In this tutorial, we're looking at section 9.5, which is on solving type 3 differential equations, which are in the form of dy dx equals f of x times g of y. So we're looking at separation of variables. So differential equations of the form dy dx equals f of x times g of y are called variable separable equations. This means basically that we can just separate our variables, so all the x's are on one side and all the y's on the other. Okay? And when we have this form, okay, then what we do is we can rearrange so we get the following. Okay? The integral of 1 on dy dy equals integral of f of x dx plus c. Okay? So we're going to look at doing a few worked examples on utilising this identity here. Okay, so the first thing that we can do is this worked example here, which is worked example 12, which is solving dy dx equals x plus 4 over y squared plus 4. So what we're going to say really is dy dx equals x plus 4 times y squared plus 4 to the power of negative 1. Okay, so this is going to be our f of x, and this is going to be our g of y. Okay, so when we build up our equation, okay, well, we need to go 1 over this function here, but this is already, you can think of this as 1 over y squared plus 4, so it's simply going to become the integral of y squared plus 4 dy, okay, and that's going to equal our integral of x plus 4 okay, dx. Okay. So we now integrate those. Okay, so we get y cubed on 3 plus 4y equals x squared plus, so x squared on 2 plus 4x plus our constant of integration. Okay, there's not a lot more we can do with this. All they ask us to do is put everything on one side. So we can say we've got y cubed on 3 plus 4y minus x squared on 2 minus 4x equals c. Okay. And that's all we need to do for that worked example. So we'll move on to the next one, which is worked example 13, which is solve the differential equation dy dx plus y equals 6x squared y given that y naught equals 1. So what we need to do is rewrite this, okay, so that we get dy dx equaling 6x squared y minus y. Okay, so what we do is we take our y out as a common factor and say y outside of 6x squared minus 1. Okay, so that's going to be our gy, this is going to be our fx. Okay, and we can simply use our identity from here. So we can say, well, we're going to integrate 1 over y dy equals the integral of 6x squared minus 1 dx. Okay, when we integrate 1 on y, we get log to the base e of the modulus of y. Equally, well, it'll be 2x cubed minus x plus c. Okay, so we also know that when x equals 0, y equals 1. Okay, so when we do that, well, we can say log to the base e of 1 equals, well, our x is a 0, so it's just going to equal c. Okay, well, that means then that c equals 0, because log to the base e of 1 is 0. So that means then what we can do is we can have a look at this. Our function up here, we know our c is 0, so if we've got log to the base e of the modulus of y equals 2x cubed minus x. Okay, then what we do is our looping method, so we can say then that y equals e to the 2x cubed minus x. Okay, and we're all done with that one. So we've got one last worked example to have a look at, which is solve dy dx plus 2x times the square root of 16 minus x squared equals 0. And we know given that y of 0 naught is equal to 4, okay, we can use that to find our integration our constant of integration, okay, and then we need to state the maximum domain. Okay, so what we're going to do, again, rearrange, so say our dy dx has to equal minus 2x times the square root of 16 minus y squared. So again, that's our f of x, that's our g of y. Okay, so we can build up our equation. So we can say then, well, we can make it minus 1 over the square root of 16 minus y squared dy equals the integral of 2x dx. Okay, so that means that we get the inverse cos of y on 4 from our previous work on equations like this equals x squared plus c. Okay, so we can substitute in our values now, so we know when x is 0, y is 4, so we go inverse cos of 4 on 4 equals, well, 0 for x squared, so equals our c. Okay, and so therefore our c equals 0 as well. So we can say that our inverse cos of y on 4 equals x squared. Okay, so that means that y on 4 equals cos of x squared. So y equals 4 cos of x squared. Okay, which is our actual final equation. Okay, but we need to state the maximum domain. Okay, so what we need to do is have a look back at this stat here. Okay, and we say, well, the range of inverse cos of x, okay, is from 0 to pi. Okay, and that means that our domain is going to be that, or our domain of our new function is going to be equal to the range of our inverse. Okay, so what we can say then is that 0 is less than x squared is less than pi. Okay, so 0 is less than x is less than square root of pi. Okay, so that would be our domain. Okay, so that's all there is for this section. Look, it's pretty similar to the last couple of sections in terms of our processes, so hopefully you won't have too much trouble completing the work on this section.